So this video is going to be a quick little video about limiting reagents, what is it, and then what it can be utilized for. So really quickly, a limiting reagent or limiting reactant is going to be our starting material that we are going to run out of quickest or first. Okay, so we commonly use this and commonly try to make this synonymous with things like recipes and like baking a cake, like I have in the first bullet point. But it's important to note that the same concept is going to apply in chemistry and our chemical reactions. So there are two main things that I have highlighted that our limiting reactant or reagent is going to tell us. The first of these is the maximum amount of product that we are able to form, and then the second of these is how much of your other reactant was used up. So really quickly, the main highlight of this slide is that we are going to need to compare each reactant in terms of how much product is able to be formed. So the reason why we're going to do it in terms of product that's able to be formed is because grams of reactants isn't going to really tell us much because they're going to have different masses. Each element and each compound is going to have a different chemical makeup, which means they're going to have different masses. So that's kind of like comparing apples and oranges, and it doesn't really make sense. We're not going to compare moles of each reactant because, as I have detailed in this little description, that's not going to consider the ratio or the proportion in which they're combined. So we might have 2 to 1 or 1 to 2, stuff like that, and it's not going to really tell us how quickly they're used up. So we need to compare in terms of how much product we're able to form, because that's going to show us the true number of what we're going to be able to produce. And obviously the one with less, the one that's going to produce less product, is our limiting. So this is a good opportunity for you to pause the slide and give this one a shot on your own. So this is practice problem number 1, the only practice problem that we will be doing, and give this a pause and try to work out A through D on your own. Okay, so what we're going to do is really the only thing that we're given in the question is we have 12 grams of glucose and 12 grams of oxygen, and I'm going to pick a starting material, and my starting material is going to be CO2. So what I'm going to do is for both of these, I'm going to compare how much I start with, so my 12 grams of glucose, and I am going to use this to determine how many moles. I'm going to keep it in moles because I'm lazy and I just want to stop there. How many moles of CO2 I'm able to make. So remember, anytime we want to go from one thing to another, so I'm trying to go from glucose to CO2, I need to use the mole ratio. And in order to use the mole ratio, everything has to be in moles. And we have to use a balanced chemical equation, which we were luckily already given. So for these, I'm not going to follow sig fig rules right here because all I'm actually trying to determine is which ones are limiting. So it's not really like a numerical answer in this one, it's just who is our limiting and who isn't. So that makes it a little bit easier for us. And then what I'm also going to do here is we notice that we have 6 over 6. I'm going to cross out the 6's because that's really the same thing as 1. And if you are trying to do quick math, it helps make your math a little bit easier. So we can see based on this that oxygen is going to produce the least number of moles of product, so our limiting reactant is oxygen, and thus what we will use from here on out. So here we want to know the maximum amount of each product in grams produced. Remember, one thing that we can tell from our limiting is the maximum number of grams of products able to be produced. So I'm going to do my molar mass, get that mole ratio, and be able to determine this. Now some of you are saying, why am I doing this all over again? because this is exactly what I did in the last slide. If you recognize that, good for you. You can keep that answer that you got from the last slide and just use it here. So this with sig figs becomes 17 grams of CO2. Then starting again with our limiting, I'm going to do the same thing, but in terms of water. And again, if you wanted to keep the answer from the last slide and you are able to kind of see and you're really comfortable with those stoichiometry and ratios and stuff like that, you are able to do that and it will make your work a little bit shorter. However, if you're unable to see that, I think the easiest thing would be to start fresh each time, because that will kind of show you what it is that you're trying to do. So we get this one to be 6.8 grams of H2O, keeping in mind sig figs. So this one, how much of our reactant's been used up? Again, starting with that 12 grams of O2. That's always where we're going to start. Then we're going to use our mole ratio. And so there's nothing saying that we have to only go from reactant to product or or reactant. Here I'm going from one reactant to another, and all this is going to tell me is with all of my oxygen, it's going to tell me how much glucose I'm going to use. 1 mole of glucose, my bad. Okay, so we get this with sig figs to be 11 grams of glucose, and what this is going to tell us, not glucose used. So we are going to use up 11 grams. So if we want to figure out how much is left over, what we're going to do is we're going to take our starting material, which is at 12, and we're going to subtract how much is used. Although for the used, I would recommend keeping the entire number in your calculator because sig figs matter, right? So we want sig figs, but we want sig figs based on what is at the end, which equals 0.74 grams of glucose, and not if we had just kept 11, then we would have gotten 1. Those are very different answers. So that is how much is left over or in excess. And then on this slide, I just have a couple extra videos in case you want even more practice or more instruction.